Life beyond starlight, how planets without stars could harbor. Life. The conventional image of a life-bearing planet often includes a star providing warmth and energy. However, the universe may hold environments where life could flourish in perpetual darkness, on planets that roam the cosmos unbound by a star's gravity. These rogue planets or free-floating planets could potentially sustain life through alternative energy sources and clever mechanisms for retaining heat. One of the primary challenges for life on a starless planet is the lack of stellar radiation, which is the main energy source for photosynthesis and maintaining surface temperatures on Earth-like worlds. However, internal heat can play a crucial role. Rogue planets, especially larger ones, can generate significant heat through the radioactive decay of elements within their core. This geothermal energy, similar to what powers hydrothermal vents on Earth's ocean floor, could potentially sustain ecosystems based on chemosynthesis, where organisms derive energy from chemical reactions rather than sunlight. Another potential energy source is tidal heating. If a rogue planet has a moon, or is part of a binary planetary system, the gravitational interaction between the bodies can cause internal friction, generating heat. This is similar to the process that warms the subsurface oceans of some moons in our own solar system, like Jupiter's Europa and Saturn's Enceladus, which are considered prime candidates for harboring life. Maintaining a habitable temperature on a starless planet also requires effective heat retention. A thick atmosphere rich in greenhouse gases could trap internal heat, creating a warming effect that could keep a surface or subsurface environment molten or liquid. Alternatively, a thick layer of ice on the surface could act as an insulating blanket, protecting a subsurface ocean warmed by geothermal or tidal forces from the frigid vacuum of space. While the surface of a rogue planet would likely be extremely cold and dark, the interior, or a subsurface ocean, could provide a stable environment with the necessary ingredients for life. A solvent, likely water, energy, and chemical building blocks. Life in such an environment might resemble the extremophiles found in deep-sea hydrothermal vents on Earth, adapted to survive in conditions without sunlight and utilizing chemosynthesis as their primary energy source. The existence of a magnetic field could also be beneficial, shielding any potential atmosphere or subsurface environment from harmful cosmic radiation. In conclusion, while the absence of a star presents significant challenges, the potential for internal heat sources, insulating layers, and alternative energy pathways suggests that life, likely microbial, could theoretically survive and even thrive on planets that wander the galaxy in solitude. The search for such life expands our understanding of the potential diversity of habitable environments beyond those that orbit stars.